So hello everyone and welcome to this video. I'm Karim 𝘎𝘠𝘎. I'm an application engineer at Elsner Elektronik. Part of my daily task is to deal with the applications for our KNX products and to provide for our customers also supports regarding those applications. And in this video, I'm going to walk you through our new application program, the Windancer 2.0 GPS KNX. And as you can see, the first change you will notice is that all the functions are now organized into categories. And in this main page, you can also find useful information for more products and solutions from Elsner Elektronik. And you can see that this device, for example, supports 𝘎𝘗𝘓 in addition to the ETS service app, which allows you to do firmware updates on site, and integrated the context help, which we will see later on. And an important part is the information to our technical support, so you can reach us more easily in case you have any questions. So those new categories will mean that as an integrator, you can go straight to the area that is relevant to your project without scrolling through everything. This becomes especially useful when you are working on larger projects with a lot of devices, where planning can easily take hours. The category structure gives you a much cleaner overview and helps you work faster. So now we will go through functions briefly, starting with the first category, the general settings. Here you will find the basic device configuration, including the location and the GPS. So under the location settings, you can either let the device determine its position automatically via the built-in GPS or enter the coordinates manually. There is also a height setting for the altitude, and you can configure also the time zone, which is the offset relative to GMT, in addition to the summertime rule. The GPS subsection, here you can tell the device how it should handle the date and time. So you can source it directly from the GPS signal or from an external object. Useful is it to have like the central time sourced on the bus. You can also define the fallback behavior. So it means what will happen when the GPS signal is not received for a configurable period of time. Now we'll move to the wind category. Here you first activate the wind measurements and configure the transmission behavior. So how often and under what conditions are those values sent on the bus? Below that, you can enable the threshold values for wind. So each threshold value you activate here will generate its own group objects and parameter page, where you can define the exact limit values. So the threshold value itself can be set in two ways, either as a fixed parameter, or you type it directly in the ETS and say this is the value that I want to use, or you can set it via a communication object. And this is the option that allows the teach-in function, which is new in our applications, and lets you set and adjust the threshold value in a runtime via a communication object. This is available across all other threshold values, and meaning that those threshold settings are similar across all other threshold functions. So via the communication object, you can define the initial threshold value that is active until the first communication that arrives. And you can also set the minimum and maximum limits. The value can never be pushed outside that range. And you also choose whether the threshold can be changed by sending an absolute value or whether an increment or decrement commands to be allowed. We will have a look on the communication object. So, triggering this object number 600, this will take the current live wind measurement and save it in the threshold value into object 602. So whatever the wind is doing at that moment becomes your new limit. You can also write a new absolute threshold value directly to the same object 602 at any time. This is especially useful for optimizing the threshold values. Object 603 handles the increment and decrement. So sending this object shifts the threshold value up or down by a defined step, always staying within the minimum and maximum limits that are configured on the parameter page. Object 606 is the output of this threshold function. As you can see, the output. And this is what you connect to your actuators or logic. When the measured value crosses the threshold, the info is sent over the bus using this object 606 to be used further by other devices. And the state of this object 606 is determined by comparing the actual wind speed against the threshold value while taking the switching distance into account. The switching distance, or the hysteresis. The output switches on when the value crosses the threshold in one direction and only switches off when it moves back past the threshold by the defined switching distance. And here you can set some other conditions for when the output is on or when the output is off. In the parameters, you can also set those switching distance and the hysteresis as absolute or as a percentage for the threshold value. The percentage option is useful when the threshold itself can change in a runtime, such as the teach in function, so that the hysteresis can automatically scale with it. And here, in this part, you can define the logic of the output. In this case, object 606, which is a state 1, and when is it state 0. You also configure the delays for switching on and switching off independently. And this is useful for avoiding rapid toggling of the dynamic conditions. So this is also a good moment to point out the context help function. For example, this parameter has a built-in help context that you can open directly here in the ETS, as you can see, and it will help you understand exactly what this parameter does and will make it less of effort for you to go and search in the manual. Similar for some other parameters. And finally, we have the sending behavior of this output, whether you want to send it by cycle or on change or both. And finally is the blocking settings. So moving on to this part, here you can configure what happens to the output when the threshold function is blocked externally via a KNX group object. You define two things independently: the value that's sent on the output when blocking becomes active, and the value that is sent when blocking is released. This gives you a full control over the fallback behavior during blocking. So important to mention that everything we just covered for the wind threshold 1, the reading type, the teach-in, the threshold values, switching distances, the output, and the blocking function applies equally to other threshold functions in the application. So you'll find the same structure for brightness, for down calculations and threshold values, and for the temperature threshold values. Each one can be configured independently and could be used to trigger different actions depending on your project. So moving on to the rain detection function. The first setting here will define the retention behavior for the delays that have been received via the communication object. You choose whether those values are kept after a power restoration or not, or whether they are kept after programming or a power supply, both at the same time. You can also activate a secondary rain detection with a fixed delay. And this means that no delay on the rain detection and 5-minute delay after dry condition. This is useful if you want a second independent output that reacts to rain with a different timing, with a specific timing. The main setting down covers the output delays. How long after the rain is detected before the output switches to on, and how long after the sensor reports a dry condition before the output releases. This delays lets you avoid false triggers from brief rain events and prevent the system from reacting too quickly when the conditions change. So in this application, we also have time switch functions. Here you can set switch on functions such as a weekly timer or a weekly period. So you set the switch on time and the switch off time, and then you can define the days of the week where the timer is active. So you can select multiple choices depending on your project. And finally, you define the sending behavior of this output the same way as all other outputs. So you can say in case of change, and in case of a cycle. We also have the calendar timer, and the calendar timer lets you define up to 4 independent time periods. It's a practical example. You would be setting this periods as 4 seasons, each for its own active window. So each period would be configured by a start date and an end date, plus the start hour and the end hour. So you can define exactly when within this day it should be activated or deactivated. And when configuring the output sending behavior, you will notice an additional output alongside the standard 1-bit. This is for both timers. And this is an 8-bit value, which means you can connect it straight to your BMS without needing an external converter to translate the 1-bit signal into a scene or a status byte. This one is less function that is most of the time needed, so you have less devices used. It's directly there for you. Speaking of the logic conversions, the application also includes built-in logic functions. You get 8 AND gates and 8 OR gates, which you can wire up freely depending on your project requirements. Each gate has 4 different inputs and has 2 outputs. It could be a 1-bit value output or a 2 8-bit objects. Those 2 8-bit objects are flexible, and you can configure them as a value 0 to 255, a percentage, a degree, an angle, or a scene, numbers of scene. So this removes also the external conversion module that you might need to use. So as for other functions, you can specify the transmission of the output, and this is when the condition is met. For example, change to 1, change to 0, or periodic change. Similarly will be the blocking reaction or blocking function for this output, as well as the monitoring, what will happen if you don't receive such input for a specified time. So finally, we'll go to the shading function. So before we get into those settings, make sure that you have at least one brightness threshold value to be activated, as this will be the reference to the facades or to the shading that you are using. So in the shading settings, you have to determine the sun position. Is it calculated or is it received? And what will happen by this value? Should you want to send it on the bus or not? Also, you can activate a heat protection function that is universal. It is a universal temperature limit that applies across all the facades. Now we start by facade number 1, and you'll see this is an information page summarizing all the keys of the functions that are included in this facade. This could be a useful reference during commissioning. So we will start now by renaming this facade to south, and this will also dynamically change the name of this facade, in addition to the communication objects for this shading, which will make it easy to detect when you go back to the group objects page. Okay, and now in the specific settings for this shading, you first select which brightness threshold this shading should react to. So you can say brightness threshold 1, 2, up to 4. And then you define the sun direction, essentially the azimuth range where you want the automation to be active. So outside this range, the facade would not be concerned even if the brightness is too high. And last part is this tracking. So a shadow edge tracking or a slat tracking, for example, the slat tracking is a function where it adjusts the slat angles to allow, at a set condition, a specific depth of light penetration, which one will use depending on the glazing in the room or the user special preference of lighting. For example, here we can see the maximum penetration depth that we want to allow it to the room. Finally, you define the actions for this facade for each condition, if the brightness is high or low, and so on. So you set the target of the blind position and the slat position. And each condition corresponds to one of the states of your logic or threshold outputs that are produced, so that the facade can behave exactly as planned for every scenario. Now let's start a smart linking action. As you can see, this device is annotated by a green logo. So you mean that it is smart linking ready, and it has the smart linking function included in it. For this example, we are also going to use an actuator from the market, which also supports this smart linking function. So after we finish the configuration of the shading, we open this smart linking explorer. It's an application from the KNX Association. You can download it from the website. So first of all, let's have a look on the group addresses. Here you can see there are a lot of group addresses, and if we want to find the one for the facade, although it's relatively easy with the search function and that we know that south is the name of this facade, but still we can do it much easier with this function. So we go here to the group addresses. We see that we have no group addresses available or generated, and this is intentional, that we want the smart linking extension to do this job for us. So we will go to the left panel view and we will go to the shading. This also view is meant to be compatible or matching the categories and sections that you have in the parameter, so you can easily find and navigate through it and find your corresponding channel. So now I will select the facade south from the Windancer and channels 1 and 2 from the actuator. And then I will drag and drop both to the Smart Linking Explorer linking field. And then you can see that the connection is made automatically. So in this Smart Linking extension or Explorer, it has matched the group addresses between the drive position to the actuator, the slat position to the actuator, and including the feedback also to the same actuator. And the corresponding group addresses, as you can see here and notice it, it's already generated. And this means less manual connections are needed, less manual work, and it does not stop here. So this part can be also extended. You can add the wind threshold value as an alarm. Additionally, you can add the rain. So all the channels which have the green icon means that they support this smart linking and are smart linking ready. You can see here in the application function, you have the rain, the wind, the positions of the slat, the position of the blind, and the move up-down status. This application function is directly added to your room. So later on, if you want to add or to connect those group addresses to your VMS or to an additional device, maybe it doesn't support smart linking, you can easily find them already added and generated for you. Additionally, you can definitely change the name, call it, for example, Blind South, and then you will have it automatically updated for you in your building view. So this video was a short overview of our new application for the Windancer 2.0 GPS KNX, and I hope the information were useful for you. If you need any more clarification, if you have any additional questions, please write to me or write to our support, and we will be happy to answer you as soon as possible. Thank you for your time, and we see you in another video.